So we talked about the two main types of bonds, ionic and covalent. We also have metallic bonds. So metallic bonds result between the attraction of two metal ions. Metals tend to give their electrons easily, so they are positively charged. And what happens is you have, for example, zinc and zinc, each with a positive charge because they give electrons. Those positive ions are attracted to the negative electrons that surround them. So these share electrons as well, but not like the covalent bonds. It's a different type of sharing. So we know there are properties of metals, good conductors, ductile, malleable. Now we want to know why. Well, it has everything to do with the way that these bonds between metals occur. So metals are great conductors of both heat and electricity because the electrons around the metal ions are free to move because the valence electrons are shared between the metal atoms. And what is electricity? It is the movement of electrons. So because metals allow this free movement of electrons, that causes electricity. So if you look at this picture, we have gold. So pretend this is a block of gold. You have a gold atom and another gold atom and another gold atom. These are all going to be positive ions. The electrons are represented by these little dots or dashes. What happens is this gold electron is attracted to this atom of gold, and this gold electron is attracted to this atom of gold, and this gold electron is attracted to this atom. So between all of these positive atoms of gold, they're just zipping around and being shared, the electrons. And once again, the movement of electrons creates electricity. This is not the same type of sharing as covalent. There's no overlap. They just kind of zip around and are within the same atom of gold throughout. So we're talking about similar atoms or identical atoms. Okay, we also know that that metals are shiny. They're lustrous. So gold, very shiny. This is zinc, very shiny. Why? It has everything to do with how the electrons take in energy. So what happens is the atom absorbs energy from light. Light energizes the electrons. But it's just like with anything, there's only so much you can take in before it has to be released. Okay, so think about drinking water. You drink a ton of water, eventually you have to go to the bathroom to release it. Same idea. So all of this energy is going to build up, but when no more can be absorbed, the excess energy is released, and it's released as visible light. To us, it looks shiny. So because these electrons are energized, when no more energy can be absorbed, it's released, and you see this visible light. Also, we know that metals are malleable and ductile. Remember that malleable means you can flatten it into a thin sheet without breaking, and ductile means you can stretch it into a thin wire without breaking. Once again, it has to do with how the bonds occur. So when you flatten or stretch out a metal, bonds do not break. That's when you get breaking of the substance occurring because bonds are breaking apart. That doesn't happen with metals. Instead, the electrons just move to adjust to the new shape. So for example, we have this piece of, we'll say aluminum, this block of aluminum. What happens is these bonds in between the atoms do not break, they just shift to move to the new shape. So it's kind of like Play-Doh. You take a ball of Play-Doh and you smash it with your fist, the Play-Doh doesn't break apart, it just squishes to the new shape. Same idea with the bonds between the metal atoms. So metallic bonds are our third most common bond. So we have ionic, covalent, metallic. We also need to talk about hydrogen bonds. Hydrogen bonds are not technically a main type of bond. They're actually an intermolecular force, meaning between a force between atoms. Hydrogen bonds are very weak, but very common because hydrogen is found in a lot of things. So in true definition, a hydrogen bond or an H bond, H for hydrogen, is an attraction of hydrogen to either oxygen O, fluorine F, or nitrogen N. That is the bond that creates an H bond. Hydrogen to fluorine, hydrogen to oxygen, or hydrogen to nitrogen. So if you look at this picture, this is a water molecule, okay? One oxygen, two hydrogens, H2O. We have another water molecule and another water molecule. I said that hydrogen bonds are intermolecular forces. Inter meaning between molecules, intermolecular. So I have 3 molecules here. If you look, we have this molecule attached to this one. And what is the attachment? An H to an O. This is a hydrogen bond between molecules. Once again, this molecule of water is holding onto this molecule of water. Where's the attachment? Between an H of one molecule and an O of another molecule. So that is an H bond, which is an intermolecular force. Very weak, but common.